everyone. Let me just check if I'm audible and visible. Can you guys let me know in the live chat if I'm audible and visible? Yes, I am. Hi, hello everyone. Yeah. We'll wait for a few minutes. Hi, hello everyone. A very warm welcome to Deeksha Vedantu YouTube channel. I hope you all are doing really great. I'm Aditi, your physics teacher, and today we are here with the chapter Light, a very important chapter for your class 10th boards. We'll start with a mind map and it will give you from 0 to 100 about the light chapter. Everything that is there in the light chapter will be included in this mind map. Don't worry, we won't skip anything. And to increase the efficiency a little bit, I have also brought you lots of numericals, lots of questions and numericals that we'll do today after the mind map in this live chat only. Okay. Hi everyone. Hi Rutuja. Good morning. Hi. Rutuja, will just wait for a few minutes, okay? I want you to share this live link with your friends, with your cousins, so that they are also preparing for boards and it will be helpful for them. Because we have started this GOAT series, and as the name suggests, it will be a GOAT revision for you guys, for your class 10 boards. Okay, can we start now? Okay, let us start with our mind map first. So the chapter is light. We know it has a high weightage in our class 10th boards. So we'll start with the very basics. What is light, ma'am? It is just a form of energy that allows us to see the world around us. Correct? Now, it is of two types. It has dual nature. What is the dual nature? It acts as particle and as well as it acts as a wave depending on the situation on which the light is kept, or like in photoelectric effect, or in sunlight, in solar cookers it acts as a particle, or in wave nature, you'll study after Young's double slit experiment and all, there it acts as a wave. Particle, it behaves like a particle, and in wave nature it behaves like a wave. Can you see the difference? This is just a particle. We name it as photon. It's just a wave. Correct? Understood till now? Very basic. We are starting with very basic, a light chapter, major weightage, but we have started with very light basics of this. Next we have what we are going to study. Two things. First is reflection of light. What is reflection of light? It's just bouncing back of light. What? Bouncing back of light when it strikes a surface. So this is my surface. This is the incoming light. We regard it as incident ray, and then it reflects and goes back. We regard it as reflected ray. Correct? Then we have what? The second phenomena, refraction of light. Refraction of light suggests bending of light. What? Bending. This was bouncing back of light. This is bending of light when it passes from one medium, to the another, having different density. So this is a rarer medium, this is a denser medium, and we know when incident ray strikes this surface, it gets bending, it bends towards the normal if it's going from rarer to denser, or if it's going from denser to rarer, then it bends away from the normal. If the ray is going like this from denser to rarer, it will bend away from the normal. Correct? Understood till now? Okay. Next topic we have laws of reflection of light. Very important. This is laws of reflection of light. What are the laws? The first is angle of incidence is equal to angle of reflection. Very easy, correct? Then the second is the incident ray, the normal to the mirror at the point of incidence, and the reflected ray. What did we study here? The incident ray, the normal ray and the reflected ray all lie in the same plane. This is my second law of reflection. Hi Arjun, it just started, just few minutes, I guess 5 minutes. It started at 11 a.m. Okay, we are starting with the mind map. We are revising the whole chapter light. Then we'll jump on to the numericals. Correct? Okay. We are here, laws of reflection of light. Are we done with the laws of reflection? Then what do we have to study? Refraction. What are the laws of refraction of light? These are, again, this is same. The incident ray, the refracted ray here, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. Correct? And this has a Snell's law. Here, angle of incidence was equal to angle of reflection. But in this particular case, in case of refraction, we have sine of I, sine of incidence, and sine of what? Refraction is constant. Correct? This is the second law of refraction. Correct? Understood till here? Very easy, very easy. Next, we want to study some instruments. So the first comes is spherical mirror. Correct? So spherical mirror, ma'am, is of two types. We know that is concave mirror and convex mirror. Concave mirror looks like a cave and light is incident from this side. Convex mirror on the other hand looks like the other side of the cave and the light gets incident from this point. Correct? Understood? These are two kinds of spherical mirrors. Correct? Then we'll move on to the images that are formed by concave mirror, a very, very, very important topic. Stay focused. So we have 6 cases. First is when the light is coming from infinity, or my object is at infinity. When my object is at infinity, the image will be formed at the focus of the concave mirror. Correct? Then I brought my object a little closer to the mirror. Then what happened? It is now beyond C. When it is beyond C, one ray goes parallel to principal axis, another passes from the center of curvature, goes back from the same point, and the image is formed between center of curvature and focus, and this is smaller in size. Correct? It's a diminished image. Correct? Understood? Then we brought our object more closer to the mirror. The object is at C, and when we know when the object is at C, the image will be formed at C again. Correct? So the image will be formed at C and it will be of same size. Correct? Understood till here? Okay, then what we did? We brought our object again more closer to the mirror. Just a second. Yeah, we brought our object more closer to the mirror, and now it is between center of curvature and focus. So again the rays will go parallel, one will go from focus, and the image formed will be beyond C, where when the object is between C and F, the image will be beyond C and the image will be enlarged. Correct? Understood? Then the fifth case says when the object is brought more closer, it is at focus, then the image will be formed at infinity. The image will be at infinity and it will be extra large, or how you say it, it will be extra large or enlarged. Then in the sixth case we have a exception. What is it? Hi Krishna, hello. At F the image would not be formed. Yeah, we can say that because at infinity we won't be able to see the image. So you can say that the image would not be formed or it will be formed at infinity. Both will be correct. Okay, then this is my focus. The image is between focus and pole. When the image is between focus and pole, we will see that the reflected rays are getting diverged. They are going away from each other. So what they do, they'll meet behind the mirror and this image will be enlarged. First, this image will be enlarged, then it will be virtual and erect. In all these cases, the image was real and inverted because real rays are meeting. Correct? But in the sixth case, the image is enlarged, it is virtual and it is erect. Yes, Arjun, you can say that that is also true, that the image is not formed, because at infinity you won't be able to see the image anyways. So you can write, yes, you can write that the image won't be able to form. Correct, this is correct. Okay, let's move on to the next part, image formed by convex mirror. Correct, this only has two cases. What are those two cases? First, the object is at any point between my infinity and pole, so the image will be formed between pole and focus. Correct, the image will be between pole and focus. And the second case is when my object is at infinity, it is very, very far. It is, hi, my name is Aditi. Hello, good morning, Trev. Hi, Tukaram. Legend, hello legend. Welcome to this live. We have started this live. We are doing mind map of light first. We are revising the whole chapter. Then we'll move on to the numericals of the same chapter in this live only. Okay. Good morning everyone. Okay, so we are studying the image formation by convex mirror. First case is my object is at any point between infinity and focus. So the image will be formed between pole and focus. Correct. Then the second case is the object is at infinity, and we know in this case particularly the image will be formed at focus. Correct. We are done by image, we are done with the mirror part. We have seen the image formed by concave mirror and the image formed by then convex mirror. Correct. We'll move on to the next part. Understood till here? You have any doubts? If anyone has any doubt till here, you can ask. Then we'll move on to the next, which is lenses. Correct. Okay, moving on to the lenses part. Yes. So, okay, first before the lenses, we'll do a quick revision of the images formed by spherical mirrors. So, from concave mirror can form a real image, and in the sixth case it was forming virtual image. So, it can form both real as well as virtual image. It can form image of all sizes, diminished, enlarged, extra large, point size. Correct. Then it can form inverted as well as erect image. These two are both the sixth case. Understood? These two are from the sixth case when the image is forming behind the mirror. Correct? Okay. Then in case of convex mirror, the image is always virtual. The real image is never formed in case of convex mirror. Then it is always diminished. The image is always smaller than the size of object. Then it's always erect. So this, in case of concave mirror, it can be real, can be inverted, it can be of all sizes, it can be erect as well as virtual. But in case of convex mirror, what? In case of convex mirror, the image is always virtual, always diminished, always erect. Okay, understood? Okay, moving on to the next part, which is now our refraction. Now first we'll see refraction from a glass. What actually happens in refraction? We studied it's just a bending of light. What? Bending of light when it passes from one medium to another which has different density. So this is air, this is water, both have different densities. So when first ray is going from air into the water, what will happen? It will bend towards the normal. Ideally it should go like this. Ideally it should go like this, but it bends towards the normal and it goes like this. Correct? Understood? This is basically what refraction is. This is all you got to know for the refraction of glass slab. And we know that N12 is equal to N1 by N2 and speed is inversely proportional. So this will be V2 by V1. This is the relationship between refractive index and the velocity of light in those particular mediums. Correct? Moving on to the next part, which is spherical lenses. Now we know spherical lenses is also of how many types? It is of 2 types. Just a minute, my laptop is not working. Why is it not working? Okay, moving on to the next part, we have 2 kinds of spherical lenses. First is concave lens again. Then second is convex lens. Similarly, the way we had two kinds of mirrors, we have two kinds of lenses. Correct, Arjun, correct. We have two kinds of lenses. First is concave lens. It looks something like this. And then we have convex lens. It's thicker from the middle, thinner from the edges. It's thicker from the edges, thinner from the middle. Then we have images formed by convex lens. Correct? Hi Jeet Das, I'm great. How are you guys doing? How was Christmas? Let me know while we study, okay? So this is the image formed by convex lens. Now again we have 6 cases here. First is when the object is at infinity. When my object is at infinity, why is it not working? When the object is at infinity, the image will be formed at focus. But now in this case, in the mirror, it was on the same side of the mirror. But in case of lenses, it will be on the other side of lenses, because lenses does not reflect. It refracts. It bends the light. So can you see the light is coming and it is bending towards the focus. Correct? So this is formed at focus, which is on the other side of the focus at f2. The image will be real and inverted. Correct? Then we brought our object closer to the lens, so it will be now beyond 2f1, and the image will be formed between between f2 and 2f2, and it will be diminished. It will be, these are similar to the cases of image formation by concave mirror. Okay, concave mirror. Convex lens is similar to concave mirror. Correct? Okay. So if my object is beyond 2f1, the image will be between 2f2 and f2. Then brought again closer to the lens, the object is at 2f2, the image will be again at 2f2. Image will be real, inverted, and of same size, just as the case in concave mirror. Diminished, yes. Okay, great, Arjun, great. Okay, then the fourth case. Now the image is between 2f1 and f1. So it is somewhere here, correct? So in this case, the image will be formed beyond 2f2. This is my 2f2. The image is formed beyond 2f2. Now this will be enlarged, and real and inverted. Correct? Understood till here? Any doubt? Then in this case, the image is at focus. Now, as Arjun is saying, we can write that the image will not be formed, or we can say that the image forms at infinity, and hence we consider that image is not formed. So at focus, at f1, the image will be either not formed, you can write not formed, or you can write at infinity. Correct? Enlarged image, Arjun, correct, very good. Big applaud for you for being present. Okay, then the sixth case, the same as we had in concave mirror. Now the object is placed between f1 and optical center here. Correct? So the image will be virtual and erect. In concave mirror case, the image is forming on behind the mirror. But in this case of lenses, all the images are formed on the other side of the lenses. Correct? So for virtual and erect, the image will be formed on the same side as that of the object. Correct? Okay. So the image will be on the same side of the object, that will be behind the lens, and it will be now virtual, erect, and enlarged. Correct? Understood all the 6 parts? Virtual and erect. Yes, Sneha. Very good. Everyone understood all these 6 points, all these 6 cases. Anyone has any doubt? You can ask right now. Anyone has any doubt about the image formation by convex lens? You can ask right now. Okay? I'm so proud of you guys for waking up or coming to the class at 11 a.m. Okay, everyone is saying yes, yes, yes. Okay, let's move on to the image formation by concave lens now. Just like convex mirror, it only has 2 cases, that is at any point between optical center and infinity, or at focus. So at first this is the second is at infinity. So first case is my object is at infinity, so that these when in case of convex lens these are getting converged, right? But in case of concave lens the rays are getting diverged. Can you see? They are getting diverged. So they meet behind the mirror at what? At focus. Correct? No doubt, ma'am. Okay, very great. Yes, Arjun is saying it will be virtual, erect and diminished. It will be virtual, erect and diminished. Correct. Now, if the second case, my image is at any point between optical center and focus. Optical center and infinity, sorry. The object is between optical center and infinity. It is at any point. So at any point the image will be formed between the optical center and f1 on the same side of the lens. So it will be virtual, it will be erect. Correct? And it will be what? It will be diminished. Here you can write diminished or you can write point size. It will be better if you write point size. Okay? Hello ma'am, happy birthday. Okay, thank you. Okay, can we move on to the next part? We are done with image formation by concave mirror, image formation by convex mirror, image formation by concave lens and image formation by convex lens. All the ray diagrams are done and we studied refraction through glass lab. So do you have any doubt till now? We are done with all the ray diagrams, correct? Okay, let's move on to the next topic. What is left? Yeah, nature of image formed by spherical lenses. So for convex lens, it can form, again, it is similar to what? Concave mirror. So it can form real as well as virtual. It can form image of all sizes and it can form inverted as well as erect image. Now in case of concave lens, it is similar to what? Convex mirror. So it is always virtual, always diminished and always erect. Correct? G ma'am, done. Okay. Numericals, yes, we are just finishing the mind map and we'll move to the questions and numericals, okay? Just few more minutes. I'm guessing it's done. Yeah, okay, done with this. Next topic is yes. For the numericals, you need what? You need formulas and we'll see what formulas we have. The mere formula for mirror calculation, for mirror numericals, you have 1 by f equals to 1 by v plus 1 by u, and magnification is minus negative of v by u or height of image divided by height of object. Correct? For lens formula, we have this, just in place of positive we have negative sign. 1 by f equals to 1 by u minus 1 by v. Correct? And for magnification, this negative sign is gayab, so there is positive v by u and hi by ho is same. Correct? We are done with now mirror formula, lens formula. What's left? What's left is, yes, we have one more topic that is refractive index. So N21 can be written by N2 divided by N1, which will be equal to V1 divided by V2, which then will be equal to sin I divided by sin R. This whole formula is very important because I know even I used to get confused between what is the relationship between a refractive index or velocity or angles. Distance u is always negative. Yes, I'm coming to that, Arjun, just in a second. So this is the refractive index and power of lens is just 1 by f when f is in meters. Correct? Power, unit of power is diopter only when the focal length is in meters. Correct? Then one more thing is sign convention, very, very important for your numericals. So as Arjun said, u is always negative. Correct? For now above the principal axis we have positive. This is for height of object. Correct? Down the principal axis, below the principal axis, this is always negative. Left hand side of the mirror, if this is my mirror, so left hand side, right hand side. Correct? So left side of the mirror is always distances from mirror on the left hand side is always negative, right hand side is always positive. Focal length for concave lens as well as concave mirror is always negative. What? It's always negative. And focal length for convex lens as well as mirror is always positive. Correct? Done with this? Then one more thing, very important thing is left, magnification. If magnification is negative, my nature of image will be real and inverted. If the magnification is positive, the nature of image will be virtual and erect. Also, if magnification is less than 1, it will be a diminished image. If magnification is greater than 1, it will be a large image. And if it is equal to 1, so it will be of same size. Correct? Done? Understood? Hi ma'am, Sukhvirat. Am I pronouncing your name correct? Hi. So we are done with the mind map of the chapter light. We revised the whole chapter in just, I guess, 25 minutes. The whole chapter is done along with the concept, along with the ray diagrams, along with the formulas, all the formulas, mirror formula, lens formula, refractive index, power, and along with the sign convention, which is the most important thing. Ma'am, like in graph, the sign convention works. Yes, correct. Like we take x-axis, y-axis. So on left hand side of the x-axis, the distances are negative. This is positive. On above y, it is positive. Down the y, it is negative. Same is with the mirror and lenses. Arjun, you are correct. Very proud. Okay, let's move on to the questions now. Before that, these are the topics I want you to practice. This refraction through a rectangular glass slab, we already did it, but go through it again, make the diagram by your own hand, okay? Then use of spherical mirror, where the spherical mirrors are used, concave mirror, convex mirror, where they are used in rear view, convex mirror is used, concave mirror is used in salons or barber shops, correct? So revise all that. Ray diagrams, make them with your own hand. Practice them, make them daily. Correct? Then the last is numericals, which we are going to see next. Correct? Again, before that, go join our WhatsApp channel. You will get all the notifications of these lives, of everything there, okay? And every day we are going live for all the subjects. If you want, you can prepare. This is the channel that you need for your boards all through from 0 to 100. We are completing everything on this channel. Okay? We are going live even every day. So don't miss this channel. Correct? Join the WhatsApp channel. It will be really helpful for you. Okay, moving on to the questions. Ma'am, I joined. Okay, thank you. Hi. Thank you so much, Arjun. It will be very helpful for you. I am guaranteeing you. Okay. So the first question is, let's look at the first question. Very conceptual question, very easy, but use your brain very slowly. Okay. Don't rush into the question. An object is placed in front of a convex mirror. Which mirror is this? Convex mirror. Then the object is placed at what? Infinity. According to the new Cartesian coordinates, the sign of the focal length and the sign of image distance in this case are respectively what? We need to tell the sign of focal length and the sign of image distance when we are using convex mirror and the object is at infinity. Can you let me know the answer? There are 4 options. They are saying focal length will be positive, but V is negative. F is negative, V is positive. Both are negative, both are positive. In case of convex mirror, yes. In case of, see, this is my convex mirror. Correct? This is my convex mirror. Let me give you a hint. On this side, we'll have the focal length, and as this diverges the ray, so the image will also be forming behind the mirror at somewhere here, let's say. So what will be the signs of focal length and the image distance from the mirror? What will be their signs? Will they be positive, negative, both positive? I want you to take out your notebooks with you. okay, so that you can solve these numericals and all that stuff. Let me know the answer. What will be the option? A, B, C, D. Anyone? I know a lot of you guys are present in the live chat. Even if you get the wrong answer, it doesn't matter. Nobody is judging you. We are here to study. We are here to learn. If you already know the right answer, there is no point of studying, right? So let me know the answers in the chat. Okay, you want me to answer? Okay, so just like I told you, all the focal length, first in case of convex mirror, either mirror or lens, focal length will always be positive. Remember this, focal length will always be positive in case of convex lens as well as mirror. Now for we know convex mirror forms virtual and erect images, virtual and erect. So for virtual and erect, in case of mirror, we will also be positive, correct? We will, no, live. We will also be positive, correct? Understood? So my answer will be what? Positive and positive, both focal length and image distance in case of convex mirror. Convex mirror will be positive. Read the question carefully, what kind of mirror or lens is given, correct? That is the important part. Okay. Hi, Mirazalam, if I'm getting your name right. Legend, am I correct? I can't see your answer, Legend. Okay, let's move on to the next question. The second question, it says, when a beam of light passes through a region of very fine dust particles, the color of light that scatters the most in that region is what? I guess this is from human eye, no? Human eye. Okay. Maybe I accidentally put the question in here. Okay, let me know. If you know the answer, let me know. Let's just get this surprise question for you. Which kind of color will scatter the most? Red, blue, orange or yellow? Will it be red or will it be blue? So we know in the scattering, we'll also study in human eye. So for now, we know that out of all the colors of the Vibgyor, blue will scatter the most, correct? So this option is blue. Okay, next question. Very important question, very important question. If the magnification produced by a lens, we have a lens, if the magnification produced by a lens has a negative value, then the image will be what? Virtual and inverted, virtual and erect, real and erect, and real and inverted. Arjun is saying red. No. They asked which color will scatter the most. So red will not scatter, blue will scatter, okay? Blue has like comparable wavelength or smaller wavelength, so blue will scatter the most. Which class? This is for 10th class CBSE Boards Physics. We are studying light chapter today. Okay, Arjun is saying real and inverted. Anyone else? Of all the people present in the live, I want you to answer. Okay, let's just see for m equals to negative. We know for m equals to negative, there can be two cases, it can be positive. So for in case of negative, it will always be real and inverted. In case of positive, it will always be virtual and erect, correct? Now you can see virtual and inverted is not a case. Real and erect is not a case. So we have only two options. So for negative, we have m is negative. So we have real and inverted image will be formed, correct? Fourth question says, oh, again a very great question. Listen to this carefully. A plane mirror is inclined to horizontal at 60 degrees. This is my horizontal. I have a plane mirror which is inclined at 60 degree. Let me just, you can make the diagram as you are studying the numerical. It will help you a lot. This is my plane mirror. This is my horizontal and it is inclined at an angle of 60 degree with the horizontal, correct? A ray of light is incident on the mirror at an angle of incidence 30 degree. So angle of incidence is 30 degree, so reflection will also be 30 degree. Angle which the reflected ray makes, but with the horizontal. This angle is with the mirror, correct? With the plane mirror. But we are asked what the angle the reflected ray will make with the horizontal, correct? Does anyone know the answer to this question? Okay, Trave, Legend, everyone said real and inverted. Very good, very good. Your answers are correct. Can anyone let me know, do you know how to solve this question? Let me know in the chat if you know. Yep. It's very simple, just use your brain a little bit. Okay, did you understand the question or not first? Let me know if you understand the question or not. What they are given, we have a plane mirror. This is my mirror, inclined to horizontal at 60 degree. This is the CBSE question. It has come in boards before, okay? So listen carefully. Kind of, ma'am, Trev is saying. This is 0 degrees, Legend is saying. Okay, let us see. To horizontal to 60 degree, a ray of light is incident on the mirror at an angle of 30 degree. So the first step that you have to do here, you have to make the normal. This is my plane mirror. Normal to this will be something like this, correct? This is my normal. So this will be 90 degree and this whole will be 90 degree. Now using little bit of geometry, this is 60 degree. If this angle is 60 degree, then this angle will be vertically opposite. It will be also 60 degree. Now, if this whole is 90, this is 60, then this will be 90 minus 60, which will be 30 degree, correct? Now read carefully. A ray of light is incident on the mirror at an angle of incidence 30 degrees. So my incident ray is being incident on this plane mirror, on this plane mirror at an angle of 30 degree, correct? So this can be my incident ray, correct? Correct? This will be my incident ray and then it will reflect at an angle of again what? 30 degree. Now I want to see angle which the reflected ray, this is my reflected ray, this is my incident ray, correct? This reflected ray makes with the horizontal. What? Horizontal. So if this is 30 and this is also 30 and this is also my horizontal, this line is also the horizontal. So this is 30 plus 30, that will be 60 degrees. This is reflected ray, this is horizontal. With horizontal, the reflected ray is making an angle of what? 60 degrees. Correct? Yes, Trev is saying 60 degree. Correct, everyone. Option C, ma'am. It won't be 0. We are asked reflected ray. If we are asked what angle incident ray is making, that will be 0 degree. We are asked what reflected ray is making with the horizontal. This is my horizontal, correct? So the reflected ray is making, yes, Trev, you were correct. So the reflected ray is making an angle of 60 degree with the horizontal. The answer is actually 60 degree. It is 60 degree. Understood, everyone? Everyone, anyone has any doubt? Okay, moving on to the next question. Very simple, very conceptual question. A student observed the reflection of light from different types of spherical mirrors. Hi, ma'am, where were you? I was a little bit busy, but now I'm back and I'll be back with all the chapters of physics. Hi, Rohit. Okay, I'll be back with all the chapters of physics. Don't worry, we'll cover the syllabus in no time. We are done. We will be done with today with light chapter. We'll do very slowly and we'll understand the concept properly. We are done with the mind map. We revised the whole chapter first and we are doing questions and numericals. Mind you, all these questions are previous years, Correct? So do not skip these questions, understand them properly, because in the boards the question will come from these questions a little bit tricky, maybe a little bit different, but it will be similar to this. Okay? Now answer me this. A student observed the reflection of light. What? Reflection of light from different types of spherical mirrors. We have just two types of spherical mirrors, concave and convex. Now he made the following statements. A concave mirror can form a magnified and real image of an object. They are saying a concave mirror can form magnified as well as real image of the object. Second is convex mirror can only form a virtual image of an object. Okay. The third is saying magnification produced by a concave mirror can be negative. So which option is true? Okay, Kenzu is saying C, option C. Arjun is also saying option C. Okay, a lot of you are saying option C. Rohit is also saying option C. Correct. Everyone is correct. All these are true. We know concave mirror forms magnified real images. Convex mirror only forms virtual, and magnification of concave can be negative. It can be positive as well, but they have written can and they haven't written only negative. Okay. So this is true. Option C is true. Everyone is correct. So proud. Okay. Moving on to the next question. This very important. Again, a CBSE previous year. A figure shows a ray of light as it travels from medium A to medium B. Okay, the whole is medium A, the other upper is medium B. Now, refractive index of the medium B relative to medium A. We need to find refractive index of B relative to medium A. Can you give me the answer? Which will be A, B, C, D? We have four options. SPG Gamer, what happened? Sukhveer also said C. SPG Gamer also said C. Correct. Each one of you is correct. SPG Gamer saying option A. Preeti is saying hi. Hi Preeti. Option A. Okay. Others, good evening. Good morning Preeti. A. I'm getting a lot of A's. Okay. Correct. Let's see if it's correct or not. So what do we need? We need N of B, refractive index of B with respect to refractive index of A. Correct? Now how can we write? Since we have angles, we'll use sine formulas. So sine formulas will be sine of I divided by sine of R. Correct? Now first thing you need to know which angle to take, the 60 degree or the 30 degree. Since this is the interface, this will be my normal. Correct? And angle of incidence and angle of refraction are always taken with the normal. So this is my I and this is my R. Angle of incidence, angle of refraction. So sine of what? 60 divided by sine of 45. Correct? So this will be root 3 by 2. This will be 1 by root 2. So the answer will be root 3 divided by root 2, which is option A. So whoever said option A, good morning ma'am. Good morning. So whoever said option A, really great. Okay. Moving on to the next question. These all questions are very important. Okay. So again, we have during a laboratory experiment, a student observes that a path of light through a rectangular glass slab. We have a rectangular glass slab. The path of light is bent twice. Choose the correct option that describes this phenomena. He is saying that the light undergoes two refractions. At the entry and at the exit. Light undergoes one reflection and one refraction. The bending of light is due to the scattering by the glass molecules. The path of light is bent due to dispersion and reflection. Lots of different words: dispersion, reflection, refraction, two refractions. board exams, I guess they are starting from 17th or 17 Feb, right? Or 7 Feb maybe. The science exam is on 25 Feb. That I know. Option B. Option B, they are saying light undergoes one reflection and one refraction. Anyone else? Kenzo is saying option A, light undergoes 2 refractions. Okay, so actually what happens is a light comes, and since it's a glass slab, so this is air, this is glass, and this is air. So it will not reflect. It is not a mirror. It is a glass. So it will refract. It will bend towards the normal, and then again while coming out, now this is rarer, denser, rarer. Here it will bend towards the normal. Coming out, it will bend away from the normal. So we are seeing 2 refractions. One at the entry, one at the exit. So option A is correct. Everyone who said option A is correct. Yes, the boards are twice this time. The second are kind of like marks improvement boards. But I want you to not take that as a leisure activity or leverage. So start studying now. This is important. This is your boards. Correct? Don't rely on the second time. So refractive index of water is 4/3. Of water is 4/3. And refractive of glass is 3/2 with respect to air, obviously. What is the refractive index of glass with respect to what? With respect to water. This is we have to find. Hello, Roshan Raj. Hi, Roshan Raj. Roshan Raj, so can you answer this? Ma'am, doubt hai. Yes, yes, please ask the doubt. We are here to solve your doubts. Let me know the doubt, and until then I want everyone to solve this question and let me know the answer. Okay. Arjun is saying C. C is 2. Okay, Arjun is saying that the answer is 2. Yes, Arjun, I saw your answer. Don't spam, okay? So, let's see if Arjun is correct or not. For N, G by NW, we just simply N of glass with respect to water will be refractive index of glass divided by refractive index of water. For glass, it's 3/2, and for water, it's 4/3. This will rather be 9/8. What I am getting option A. Good morning, Raman Singh. Tushika Kumari. Okay, hi Tushika. Yes, Sanatam. Please ask your doubt. Good morning. So Arjun, did you understand? Did you get the calculation? The actual answer will not be 2. It will be 9/8. This will be the calculation. I guess you switched it or something. Okay, let's move on to the next question. 9th question, read it carefully. We'll solve it carefully, okay. The convex mirror. First, write down whatever mirror it is mentioned in the question. So, a convex mirror used for rear view for an automobile has a focal length. It has a focal length of 30 meters. If a bus is located at 60 meter from this mirror. So, bus is what? Is my object. 60 meter from the mirror. Use mirror formula to find the position of image of the bus. So, we need to find the position of image of the bus as seen in the mirror. Ma'am, आप कहाँ से हो? I am from Punjab. Okay. First, we have to do, we saw convex mirror. Why we focus so much on the kind of mirror we are using? To decipher the sign of focal length, correct? U is always negative. So, U is always negative, we don't mind. But the focal length sign depends on the kind of mirror we are using. For convex mirror, focal length is always positive, correct? Understood? Okay, now we need to find the position of image. Using mirror formula, what is mirror formula? 1/V plus 1/U. If anyone wants to answer this question, answer. What Satyam is saying, I am from Nepal. Hi, from Punjab, hi to Nepal. Okay, so this is 1 by 30 equals to 1 by V we have to find plus 1 by U is actually minus, so we can write minus 1 by 60. So 1 by V will be what? 1 by V will be 1 by 30 plus 1 by 60. We can just take the LCM. 2 plus 1, this will be 3 by 60, it will be 20. So focal, so V will be 20 meters. Correct? Do we have? We have 20 meters. मैम पेड लेक्चर है क्या? अरे जब फ्री में मिल रहा है तो पेड क्यों चाहिए? Kenzu and Sanatam is okay. Kenzu is saying option B. Trev is saying option A. It's actually option B, Trev. Yes, Kenzu, you are correct. The answer is option B. Correct? Understood? Can we move on to the next question? How is this negative? You tell me. We have solved. The focal length is positive for convex mirror. We know that. And one more thing, in case of convex mirror, the image is always virtual and direct. It is formed on the other side of the mirror. See, this is my convex mirror. This is somewhere the object is. So the image is always formed on right hand side of the mirror. So we know V is positive. Okay, let's move on to the next question. 10th question says, at what distance from a convex lens? We are given convex lens. At what distance from convex lens should an object be placed? Should an object be placed so we need to find U. To get an image of the same size, the image should be of same size of the object on the screen. Correct? So it should be beyond twice the focal length, at the principal focus, at twice the focal length, or between optical center of the lens and principal focus. What will be the answer? Correct. Quick. Let me know. This is very easy. We have a convex lens. This is my convex lens, where the object should be placed so that the image, height of image should be same as that of the object. Kenju Arjun is saying C. Answer is C. Correct. Answer is C. When it is placed at 2F, the image will be always also formed at 2F. This will be 2F1, this will be 2F2. Correct? But the image will always be of same size at 2F. Correct? 11th question. Again, you need a little bit of copy. A concave mirror. Again, write down the kind of mirror or lens we are given with. The concave mirror produces 3 times enlarged real image. Now, this part is very important. They are saying 3 times enlarged. So, this 3 times is what? It is magnification. So, this is 3 times, correct? But it is given that it is a real image. So, for real image, we know magnification is always what? It's always negative. That's how you decide the signs, correct? Hi Bharathan, hi. Correct? This is how you define the sign of magnification. Read the question carefully. This is fine 3 times. This is magnification, but it's giving enlarged plus real image. For real, the sign of magnification is negative. Okay. Of an object placed at 12 centimeter. So, object is placed at minus 12 centimeter. Correct? Calculate the radius of curvature of the mirror. We have to find radius of curvature of the mirror. Can you guys solve this question? I am waiting here. Can you guys solve this question? I want to know what you guys come up with the answers. The answers you will come up with. I've asked you to keep a pen and paper with you, right? This is why. Why I stress so much on you solving it, because that's how you learn, that's how you practice. You come here, I solve questions for you. That will not help you in your boards. In your boards, you will be there. You have to solve the questions with your own hand. So grab a pen and a paper and solve the questions by yourself. I'll do it In 2 minutes I'll do the solution, but I want you to also do it and check whether you were correct or not. Kenzu, Bharat, Arjun, Trev, I want all of you, Sanatam, I want all of you to solve this question. Very important, again a CBSE PYQ. Okay, let's solve this question. I hope you are honest with yourself and with me. Okay, so first thing first, we are given a mirror. So for mirror, the magnification formula is always minus V by U, correct? Magnification is given minus 3. V, we need to find. Why? Because we need to find radius of curvature. For radius of curvature, we will need focal length. For focal length, we have U, we will need V. Because from mirror formula, we need FVU. Okay, Kenzu is saying the answer is B. Let's check. Okay, so this will be minus and U is given, that is minus 12 centimeter. So here this will cancel and we will be minus 36 centimeter. Correct? This is correct. Then okay, what is next? We are done with V, then we need focal length. Now for mirror formula, it will be 1 by V plus 1 by U, correct? Now V is minus 1 by 36 and U is minus 1 by 12. This will be 36 minus 1 minus 4, correct? 3. This will be 3, this will be minus 4 by 36, this will be 9. So focal length will be minus 9 centimeter. Now, I want you to remember one thing, I want you to remind one thing. For concave mirror, we know that focal length is always what? It's always negative. We studied it, right? We engraved it in our brain. And here we are also getting a negative focal length. So that's how we know my answer is correct. Okay? And then radius of curvature is just 2 times of focal length. 2 into minus 9 will be minus 18 centimeters. So the answer is, it's minus 18 centimeter. Kenzu was correct. Absolutely correct. Very good. I'm so proud of you. Okay. All this calculation you did by yourself, then no one can beat you in your boards. Any kind of question comes, you will be able to solve it. Guarantee you, I can guarantee you, right? I can write it here. Okay, 12th question. 12th question says, a student is studying about magnification produced by a spherical mirror and make the following statement. Magnification produced by a convex mirror. Write it down, all the important points. Convex mirror is always positive and less than 1, correct? Magnification produced by a concave mirror can be positive, negative or 1. Okay. And the magnification of minus 2. If magnification is minus 2, that means my image is real. It is twice the size of object. Okay. They are asking which of these is true. Which of these is a correct statement. Let me know in the chat. Which of these is the correct statement? First and second, first and third, all of them are correct, or second and third. Okay. So, let me know the answer if you know. Okay. So, for this, we know, ma'am, this is very easy. For convex mirror, we know that the image is formed always virtual and direct, and for virtual and direct, magnification is always positive, and in case of convex mirror, the image is formed is always diminished, so it will always be less than 1, correct? Then in case of concave mirror, the concave mirror forms real, inverted, virtual, erect, diminished, enlarged and of same size, correct? So this is virtual and direct. This is real and inverted, and this is of same size. So this is also true, this is also true. If magnification is minus 2, as magnification is negative, hi Sanatam again. If magnification is minus 2, so minus indicates real, 2 indicates 2 times of object. So this is correct. So all these statements are correct, and hence we have an answer which is all the statements are correct. Answer C. Moving on to the 13th question, again a very good question. The question says a spherical mirror has a radius of curvature of 20 centimeter. We are given that a spherical mirror has a radius of curvature of 20 centimeter, which is shown in the below diagram. Find its focal length. We just need to find its focal length. So it's very easy. We'll skip this step. The focal length will just be radius of half of radius of curvature, that will be 10 centimeter. Correct? Now, let me know this type of mirror. Identify the type of mirror that always forms diminished, erect and virtual images. Namaste, cat lover. I remember your name. Cat lover. Okay, cat lover. Tell me which mirror, which kind of mirror this is. Which kind of mirror this is? Anyone knows? Okay, so as you can clearly see in the image that this mirror is what? This mirror is a convex mirror. Also, you can see the radius of curvature and focal length given is positive. If positive, positive focal length is for convex mirror only. For concave mirror, the focal length is always negative. Correct? Now, they asked, state one use of this mirror. Simple, ma'am, this mirror is used as a rear view mirror in the vehicles. Rear view mirrors in the vehicles. I've also made a short for you guys explaining that. Okay? Okay. 14th question that says, state two characteristics of the image formed in case of the mirror used by barbers. So, first tell me what kind of mirror is used by barbers. What is the kind of mirror the barbers use? That will be simply very easy. That will be what? They use concave mirror. Why they use concave mirror? Because it forms enlarged image. Correct? And two characteristics will also include, it forms a real image and it forms a inverted image. And main reason why barbers use is because it forms, hi, Jai Shri Ram, Sanatam. This will form a enlarged image. Correct? Okay. For a convex mirror, now we have a convex mirror. For convex mirror, focal length is minus 30 centimeter. Okay, something is wrong, I guess. Either this image mirror is convex, not convex, it's concave, because convex mirror cannot have negative focal length, correct? So the mirror should be concave, I guess. Concave. For concave mirror of focal length minus 30 centimeter and U is what? It is minus 50 centimeter. Find the image distance. We just need to find image distance. Can you find it? As we are given that this is a mirror, we'll simply use mirror formula. Can you see how easy these questions are? You just have to use a little bit of your brain. Okay, so focal length is minus 1 by 30 and 1 by V we don't know, we need to find, and 1 by U is minus 1 by 50. For V, to find V, we'll just switch. This will be minus 1 by 30, this will be plus 1 by 50. We'll take their LCMs, 150 minus 5 plus 3, this will be minus 2 by 150. So, V will be minus 75 centimeter, which is correct because my U is between C and F and the image will now be real and inverted. So, it has a negative sign and it is minus 75 centimeter, which is beyond the center of curvature. Correct? Understood? Let's move on to the next question. That is 15th. Very important, very good question. Very easy but very good question. A path of ray of light coming from air, this is air, passing through a rectangular glass slab traced by 4 students A, B, C, D. Which one of them is correct? Which of the students has traced the path of light from a rectangular glass slab correctly? Can you guys give the answer? Which will be the correct path of the light entering a glass slab? Okay, so we know we just studied glass slab and we did the numericals. So let's make our own diagram. What will happen? So this will be my incident ray, correct? If this is air, this is glass, so this is rarer, this is denser. So this will be normal, this will bend towards the normal, correct? Again while coming out, now this is denser and this is rarer. So this will bend away from the normal, correct? So the correct path will be what? The correct path will be B. Correct? Understood everyone? The correct option will be B. Everyone understood? Okay, let's move on to the next question. 16th question. Okay, needs a little bit of calculation. It says absolute refractive index of glass. Absolute refractive index of glass is 3/2. Refractive index of water is 4/3 respectively. Then if the speed of light in glass, we have speed of light in glass is 2 into 10 raised to power 8 meter per second, what will be the speed of light in water is? Honey is saying answer is option B. For which? This question or the previous question? The previous question we didn't, yes, for the previous question the answer will be option B. Correct, Honey. Okay, let me know the answer to this question. You just need to remember the relationship between refractive index and the velocity of light in different mediums, how these are connected. Can you solve this? It's very simple. We studied, I told you that relationship is very important, right? So that relationship is basically what? N1 divided by N2 will be V2 divided by V1, correct? So here Ng by Nw equals to Vw and Vg, correct? So Ng is 3/2, this is 3/2 divided by Nw is 4/3. Now Vw we need to find, correct? And V of glass is 2 into 10 raised to power 8 meter per second. So if you just simply solve this, this will be 9/8 into 2 into 10 raised to power 8 meter per second. So this will be 9/4 into 10 raised to power 8 meter per second. Do we have this option? Yes, we have this option. So our calculation is correct. Okay, understood? All this calculation is very important. You just have to practice it by yourself, correct? Okay, moving on to the next 17th question. It says an object placed at a distance of 30 centimeter in front of a convex mirror. Very important, write the mirror that is given. This is convex mirror. So they are saying the object is placed at a distance of 30 centimeter. Now object is always negative, correct? Object is always negative. Then what they are asking, of focal length 15 centimeter. Now focal length is also given. This is 15 centimeter. Now this is a convex mirror, correct? This is a convex mirror. So the focal length will be what? Focal length will be positive. Write 4 characteristics of the image formed by the mirror. Refractive index in short. Yeah, so refractive index is basically a property related to the refraction. So what is refraction? Bending of light from one medium to another. This is my medium. If the light comes like this, if this is rarer, denser, it will bend towards. So how much the light is bending, correct? The extent by which this light will bend depends on the refractive index of the medium. So this is air and this is water. So both will have different refractive index, correct? So the light will bend, let's say here 30 degrees. But if this is glass, this is glass and this is air, same. So in here the angle through which light will bend will not be 30 degree, correct? Because water has different property and glass has different property, different refractive index, correct? So the extent by which the light bends in a particular medium depends on its refractive index, and refractive index is nothing but it says how much the light will travel, the speed of light in that medium, how much it will bend, correct? Understood? Okay. Now focusing on this question again. What it says, it wants us 4 characteristics. Now you can do 2 things. You can first find out what is the value of V in this case, but they've only asked us 4 characteristics. They didn't ask us the distance of image, correct? So this is where you use your brain. This is where you save your time. So this is a convex mirror. Now convex mirror, I know, will always form virtual image. It will always form erect image, and it will always form a diminished image, correct? We are done. Instead of wasting your time in finding the value of V in this case and then deciphering from the negative sign from the positive sign, you can just write the characteristics of the image that are engraved in your brain from now till now. Okay, now this object is at any point, it's not at infinity, it is at some point between infinity and focus. So your image will be formed between pole and focus, correct? We are done with 4 characteristics. Okay, 18th question. Which of the following can make a parallel beam of light when light from a point source is incident on it? They are saying which of these can make a parallel beam of light, concave convex lens or concave lens or 2 plane mirrors placed 90 degree to each other, and concave mirror as well as concave lens. So this is my convex lens and convex mirror. No, concave mirror. Okay, so the first option is concave mirror, which is this one, or convex lens, convex mirror as well as concave lens, 2 plane mirrors at 90 degree, concave mirror as well as concave lens. So which of these is true? Okay, let me know in the live chat, what do you think? Which of these statements is true? Which of these instruments can form a parallel beam of light when light from a point source, is incident on it? Okay, let's just see again. This is a very easy question, but it's a very important questions. You'll have CBQs, you'll have questions, conceptual questions in your boards, and this is very important to clear your concepts. Okay, so let's see. Ma'am, I know that in case of concave mirror, if I place the object at focus, the image is, the rays then go parallel. Okay, sorry, the rays then go parallel, correct, after reflecting, correct? So concave mirror is correct, but concave mirror is here also, concave mirror is here also. In case of convex mirror, we know it has only 2 cases. At any point if the object is present, the image will be formed between pole and focus. So convex mirror is not the true answer. This is not the true answer, correct? Plane mirrors at 90 degree is never a true answer in case of parallel beams of light, correct? Then we are just left with concave mirror and concave mirror. In here it's concave lens. In case of concave lens, the rays, we also again have 2 cases. Anywhere the point is placed, the object is placed, the image will formed between pole and, between pole and focus, correct? So we are left. So concave lens is also not an option. So the correct option is concave mirror as well as convex lens, because we know they are kind of very similar to each other, correct? Understood? We are nearing to the end of this live. If you have any doubt, you can ask. Okay? Just the last question. It says assertion, reason question. This will also come in your boards. Pay attention to it. convex mirror is used as a rear view mirror. They are saying convex mirror is used as a rear view mirror. Okay, that is correct, we know that. Reason is convex mirror always forms inverted image. Does convex mirror forms inverted image? No ma'am, we know convex mirror, concave mirror forms inverted image, but convex mirror always forms virtual, erect as well as diminished image. If they have written here that convex mirror always forms diminished image, then this will be true. But they have written that the convex mirror always forms inverted image, but we know convex mirror never forms inverted image. Correct? So this assertion is correct, but reason is not correct. So C will be the answer. Assertion is true, but the reason is false. Correct? Understood? Here we are done with our life, my kids. We are done with our life. I want you to join the WhatsApp channel, like this live if you liked the mind map, if you liked the questions. We will be coming with lots of new questions, lots of revision for you guys so that you can ace your class 10 boards like this live session, and I want you to join this WhatsApp channel. So series is true. So take advantage of this as much as you can. I know a lot of you will not be able to pay for other courses or whatever, but here we are teaching you everything from 0 to 100, from A to Z, everything we are bringing for you in this live. Every chapter of every subject with mind maps, with the questions, with PYQs. So go join our WhatsApp channel. I don't want you to miss anything. And of course, subscribe the channel. This is the channel that will make you a topper in class 10th physics, in class 10th all subjects. Okay? Till then, we'll meet you in the next live with the next chapter. I am guessing it's electricity. Come for you. We'll do a lots of numericals, lots of revision. And till then, tata bye bye.